All right, so this video is to replace what we would have done in our review session today. So you can have your calculator out, have your notebook out, and file through and do the problems as we go through. Or if you want to do another great idea would be once you see the problem, just pause the video, see if you can do the problem, and then you can play the video and just check your answer. If you didn't get it right, then watch through the problem being worked out. If you did get it right, then you can just move on. All right, so we want to find the quotient and remainder. So we have two ways that we can do this. This is a candidate for synthetic division because we're dividing by something that's linear and it has a 1 in front of the x. So we're going to show both options. First, we'll do the synthetic division option. Outside, we'll put whatever makes the bottom 0, which would be a 2. Inside, we'll put each of our coefficients, and we always have to be careful if anything's missing. In this case, we're missing an x squared, so we'll have to hold that spot with a 0. We always drop down the first value. Then we'll multiply the 5 and 2 to get 10. We'll add the 0 and 10. Then we'll multiply the 2 and the 10 to get 20. We will add to get 13. We will multiply to get 26, and we'll add to get 27. Our answer is always 1 degree less than what we started with. We started with an x cubed, so we will have 5x squared plus 10x plus 13. And then our remainder, we will have plus 27 over what we were dividing by, the x minus 2. Now, if this question had said, is x minus 2 a factor? We would be able to determine from this as well that it is not a factor because we did not get a remainder of 0. We got a remainder of 27. But if it's asking you for a remainder, it's probably quicker to just sub in that value that makes the denominator 0. So sub in the 2, and that will directly give you the remainder. Now, the other method is our long division. So on the outside, we will put exactly what's on the bottom, the x minus 2. On the inside, we've again got to watch out for anything missing. So we'll have 5x cubed. We'll do plus 0x squared minus 7x plus 1. We need to ask ourselves what times x gives us 5x cubed. Well, that would be a 5x squared. We'll multiply that through to both, and we'll get 5x cubed minus 10x squared. Well, that second thing we want to subtract, so it switches all of the signs. Now we just do whatever the signs say. So a 5x cubed minus 5x cubed, that would give us a 0, so that's gone. And a 0x squared plus 10x squared gives us 10x squared. And then we can bring down whatever was left. Now we'll ask ourselves what times x gives us 10x squared? Well, that would be a plus 10x. We'll multiply that through to both, so we get 10x squared minus 20x. But we're going to subtract, so each of the things in the second part, their signs switch. 10x squared minus 10x squared is 0. Negative 7x plus 20x will give us 13x, and we'll bring down the 1. So now the question is, what times x gives us 13x? So that would be a plus 13. We'll multiply that through, and we will get 13x minus 26. Again, we're subtracting, so we'll switch both those signs. 13x minus 13x, that is 0. 1 plus 26 gives us 27. Nothing times an x will give us 27, so that's our remainder. So we'll put a plus because it's a positive 27. If it was a minus, we would have put a minus. And we have 27 over x minus 2. And that would be our quotient and remainder. Okay, here's our second question. Again, a good idea might be to just pause it right now, see if you can do it on your own paper, and then check the answer. And if you didn't get it right, watch it all the way through. If you did get it right, then just skip ahead to the next problem. So we've got our function e to the 3x. We want to find the average rate of change. Hopefully when we hear average rate of change, it pops in our head that we want to do slope. So we are going to have 2 points here. They tell us the interval -1 to 2. So we're going to have -1 comma something, and we're going to have 2 comma something. Now to get the something, the y value, we'll just sub into our equation. So we're going to do in our calculator e to the 3 times -1, and that's going to go here. and we'll do e times 3 to the 2, and that's going to go there. So for the -1, we should get 0.04978 and other stuff, and we'll just keep it out in the calculator. For the 2, we should get 403.4287 and some other stuff. So now we'll just do a slope. So we'll do the 403.4287 dot 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 minus 0.04978 dot dot dot. And now that by dot dot dot, you need to go up and select those in your calculator so you're using the entire thing. And then we have 2 minus a -1. So if we punch this in our calculators, again, make sure you go up and select the entire thing. We should get 134.4596 and some other stuff. Question asked us to round to the nearest hundredth, so we look one spot past the hundredths. We have the 9. 9 tells us to bump up, so we should have 134.46. Now these are all technically free response questions. If in the free response question it ever gives you units, remember to label those units. Reread the question, it'll tell you what the units are right in the question. So here's our next one. We're going to solve this, and we're going to leave our answer in simplest radical form. So the fact they told us simplest radical form, that is a clue that we should be using the quadratic formula. Go right to your reference sheet, and you have the quadratic formula. The one thing we want to add is we want to put our b in parentheses and then squared. But other than that, you'll just copy it right from the reference sheet. Always make sure everything's on one side before picking out your a, b, and c. For us, a is 2, b is a -4, and c is -3. So we'll have x equals minus our b value will give us a +4, plus or minus the square root. Well, we will have -4 squared minus 4 times 2 times -3 all over 2 times 2. So next we want to do just the part that is inside the radical. Okay, don't put the actual radical in, just put the numbers in that are underneath the radical there. And when we do that, we should get 40. And I'm also going to simplify the denominator to be 4. So next we want to go to our calculator, and we want to do a menu number factor. And we're going to put the 40 in. So again, we're going to a calculator page, and you're doing menu, number, and factor. Put in the 40, and it gives us 2 to the 3rd times 5. So off to the side, I'm going to do this. So we'll have 2 times 2 times 2 times 5. The square root, so we circle any pairs. 1, 2 from that pair goes inside. We still have 2 times 5 inside, so that's really 2 radical 10. So we'll rewrite this as x equals 4 plus or minus 2 square root of 10 over 4. And then our last step, we have 2 options. We can either keep it as one fraction, and if we do that, we're looking at the 3 spots not under the radical and seeing what divides all of them. Well, 2 can divide all of them, so that would give us 2 plus or minus. We would just have a 1 times square root of 10, and it's up to you if you want to write the 1 all over 2. So all those circled blue things we divided by 2. The other option is we could divide them individually by 4. 4 divided by 4 is 1, plus or minus. 2 divided by 4 is a half, and then square root of 10. So both of these would be correct answers, and if it's a multiple choice, they could have it written either way, so you want to be comfortable with each. Now, if we had had a negative under the radical, we know a negative under the radical, an imaginary I comes out. And if that's the case, we need to write our answer like the one on the right-hand side, so it's 2 separate parts. All right, question 4 is a two-parter. So we have $700 invested for 10 years. Part A, we're going to find out how much is in the account if it's compounded monthly, and part B, if it's compounded continuously. So these two questions use formulas that we wrote on our inside cover that you want to make sure you are studying tonight. So our one, when we're compounded a certain number of times, is A equals P times 1 plus R over N raised to the NT. So we will have A equals, our P, our principal amount was 700. We'll have 1 plus, oh, I guess I forgot to tell in the question what the percentage was. So we've got to add that in. Let's say it was at 4%. So we have 4%, so we would have 0.04 for our R. N is the number of compounds that we would have in a year, and if we're doing monthly, that would be 12. And then we'll be raised to the 12 times T, the number of years. So 12 times 10. Okay, some things that could change in this question. If I had said compound quarterly, we would have, instead of the 12, we would have 4. If we said compound semi-annually, we would have 2 instead of the 12. Those are the other common ones that you will see. So if we sub this into the calculator, we're working with money, so they don't have to tell us. We should automatically know that it's going to be rounded to the nearest cent. So this would give us 1043.5828. So we look one spot after the hundredths, the last cent spot, to 2, so we're keeping it the same. Our label would be our dollar sign in this case. So we have $1,043.58. Now, if we're compounding continuously, our formula from our inside cover of our booklet is A equals P times E raised to the RT. E is just our number in our calculator. So we will have A equals 700. We'll have E raised to the 0.04, and our T was 10. If by chance you ever had continuous and it was something that was decaying or shrinking, we would just put that R in as a negative. So we will go ahead and put this in our calculator, and when we do that, we get 10442772. I forgot my point there. It's after the 4. So to the nearest hundredth, we would want to look at this spot, and it would tell us if we round up or stay the same. Well, the 7 tells us to round up. So again, put your dollar sign in. That's your label. 1,044.28 we would have to the nearest hundredth. Now we saw a question on a quiz that then asked us to find which one yielded more money and how much more. Well, if that was the case, then you would subtract them and just state that the compound continuously one yielded a little bit more. Alrighty, so we want to find the focus and the directrix. Okay, this can be done right on the calculator. So we can graph our equation on a graphs page. We have 1/4 x minus 3 squared plus 1. So we'll do Control Doc to add a graphs page. So again, we have 1/4. We have x minus 3 squared. And what was at the end? We had a plus 1. Okay, so we have that parabola. So if we want to find the focus and the directrix, we'll do focus first, but directrix is essentially the same path. We've got menu, analyze graph, analyze conics. We'll go to foci, that's just the plural of focus. We'll touch our graph, and it gives us 3, 2 for that. So our focus is 3, 2. And if we go back, we can follow a similar path for the directrix. Menu, analyze graph, analyze conics, and directrix. So we'll select our graph and notice it pops up that it's y equals 0 would be the equation of our directrix. So if you see that, you can do it on right on the calculator. Now if it happened to be a free response, just draw a picture of your graph and label where the focus and the directrix are, and that should be enough work to get full credit. All right, next one, we've got f of x is equal to 3/2 x minus 4. And we want to find, we've got an f with a -1 in x. So f -1 in x, we need to recognize that means inverse. And when you do the inverse, you switch the x and y. So we're doing this as a multiple choice. So I gave 4 choices there. Now remember, the easiest way to do this, if it's a multiple choice, is just to pick out 2 points from a graphs page and then switch the x and y. So if we go to our graphs page, we can graph 3/2 x minus 4. We'll add a new graph. Okay, we'll go to our table with a control T, and we'll just pick out 2 nice points. So 2 that are there, we have 2, -1, and 4, 2. So our inverse should have those points switched. So we just flip-flop the x and the y. And then we would just test each of these to see which one has it in their table. So for example, we do -3/2 x plus 4. We would put that, and I would suggest do it in a new graphs page. So we have minus 3/2 x plus 4. So just to refresh our memory, we're looking for -1, 2, and 2, 4. So if we go to the table, we can see pretty clearly it doesn't have 2, 4. It has 2, 1. So that tells us that choice A is not correct. And then we would just go through and we would find which of those matches. But we're also going to show you the algebraic way to do it. So we'll figure out which one it is by doing the algebraic way. But on the test, probably the easiest way to do it if it's a multiple choice is just keep going like we did there. So the algebraic way, f of x is like a y. So when we switch our x and y, that would give us x equals 3/2 y minus 4. Well, we'll start out by adding the 4 over. And we'll have x plus 4 equals 3/2 y. Personally, I like to do this in 2 steps. The opposite of dividing by 2 is multiplying by 2. We just have to make sure we multiply everything by 2. So we would get 2x plus 8 equals 3y, because the divide by 2 and multiply by 2 wipe each other out. And then we've just got to divide everything by 3. So we have 2/3 x plus 8/3 is equal to y. And that y is really our inverse, so notice that matches choice C. Alrighty, our next one. To do this algebraically, we would have to do elimination several times and then go from there. We're just going to show in this video a reminder of how you can do this on the calculator if it's a multiple choice question. So on our calculator, let's go to a calculator page. We would want to go to Menu, Algebra, and number 2, solve system of equations. We have 3 equations. Now I've found if you try to do down now, it switches it to 3. So use tab to get to the next box. Notice it has X, Y, Z, and we'll hit OK. Now, if your problem had like A, B, and C instead of X, Y, and Z, just think of the A as like your X, the B as your Y, and your C as your Z, and so on. So we'll put in our equations. So we have X plus Y minus Z equals -4. And next, -2x plus 4y plus 2z. Is equal to -10. And the last one, negative 3x plus y plus 3z was equal to 0. Let's see, something doesn't look right. So I've never seen the LinSolve do this before, but they're telling us the y is negative 3 and that our x is really one thing less than the other one. So it should have been 1, negative 3, and 2. And I'm thinking that just the way it's programmed, maybe it doesn't like the 0 there. Because if I switch this to a 4, because z was supposed to be 2, then this should have now been a 2. And if we see, it works now. So it's just something in the programming of the calculator. I'm thinking maybe it doesn't like the 0 there. Odds are, if you're given this on the test, it's not going to have an equals 0. It'll have equals some other number. So you should be in good shape to use that. All right, last one I want to look at is if you had this for a multiple choice. If you're given any type of graph and they want to know which equation matches the graph, all you want to do is first set your window to match what the picture looks like. So we are going to have our window go from 0 to pi and then from negative 0.5 to 0.5. Now, one other thing is we want to be in radian mode tomorrow. So when you go in test mode, put in radian mode. But if you forget that, go home 5.2 and make sure your angle's on radian and do make default. Usually your graphs page is already on radian. Usually it's kept that way. But the calculator page, you would want to be on radian. Okay, so if we added a new graphs page, and we are going to set our window. So we want the top and bottom to be 5 and negative 0.5. And for the x's, we'll go from 0 to pi. So we can double click here. And we'll do 0.5. Now I just learned this the other day from Adrian. He showed me that you could hit tab and it'll take you to the next one. So we were going from 0 to pi for the x's. So for this one, I'll go down here, select pi, and you hit tab, and it goes to the next one. Well, we wanted minus 0.5. We can hit tab, go to the next one, and we wanted that to be 0. And now our window matches with what we wanted. Now, the other way you could have done that is you could have done menu, window zoom, and window settings, and you could have set each of them here for the xmin, xmax, and so forth. So we will, now that we have the proper window, just sketch each of the test each of the equations. So we have 1/2 cos 2x. So remember, to bring up a graphing line, you can just hit tab. So we'll have 1/2 cos 2x. And we'll see if that looks like the graph that we have. Well, it's starting high. It should hit 1 minimum and come back. And that looks pretty good. We want to check just the others just to be sure. So the next one is just y equals cos x. Remember to hit tab. So we'll have trig. We'll do cos x. Okay, so that green one is clearly not it. That does not match. Next one, we have 1/2 cos x. Now, something you can do if you want, because we know the green one's definitely not correct, I can go back up here and I can edit this to make it the next one we want to check, and just keep that one that we think might be the one. So 1/2 cos x, that still doesn't match what we see in our window, so that one's no good. So it looks like 1 is best so far, and then 2 cos 1/2 x. So again, I'm going to tab and scroll up one. So again, we had 2 cos 1/2 x. Now, if you didn't want to just edit previous ones, you could put in a brand new one each time. Okay, and the green now is over there. So the first one, the pink one there, clearly matched the best. So we would have choice 1. So just anytime they're giving you a graph and they want to know which one's the equation, set your window to the window that you see in the picture first, and then test each of the equations. So this is what we would have done at the review session today. So hopefully this was of some help to get you ready for tomorrow.